Hello, everyone, and welcome to ETCSO TV. I have with me today uh, Akhilesh Tuteja, who is the Global Head for Cybersecurity Consulting for KPMG. Akhilesh is one of the leading voices on cybersecurity matters, and he has spoken extensively on various aspects and dimensions of cybersecurity. And today I'm going to be talking to Akhilesh about something which probably has not been as much spoken about as the perimeter security or endpoint security and network security. Welcome, Akhilesh. Thank you so much for taking out time today.
Thank you for inviting me. Pleasure to meet you.
So, Akhilesh, like I said, I'm not going to be talking about the usual suspects here, the endpoint network, etc. What I really want to talk about is artificial intelligence. I mean, the fact that artificial intelligence has proliferated is an understatement. I think it's there in all aspects of our life, whether it is predicting weather or using Google Maps to find the way, to find location, or whether it is Siri or Alexa. And if we come to the workplace, of course, there are so many use cases and more use cases that organizations are today exploring. Uh, what happens, what are the security implications when this AI is hacked or this AI is compromised?
Thank you, Shipra, for bringing up that not so spoken about topic. It's a very important debate most people are working on. Unlike many of those areas which we use classically in our organization, which is typically I call the programmatic technology, we have better control on how to deal with it. But when it comes to AI as a broader context, machine learning models, deep learning models, and those programs are self-learning, it is a very complicated world for a cybersecurity expert. The proliferation, as you said, that of these kind of things is there in our world. Every single time you look at a new project coming up, you won't find a project without having an implication of either a machine learning built into it or some sort of artificial intelligence component coming into it. Now, the good news is that a lot of machine learning which is happening in today's enterprises is actually rather controlled. But the time is not far when we are going to introduce a large number of machine learning programs which are truly self learning programs, which are truly artificial intelligence of the highest level, and they may have less ability for us to control. Some of those things which I'm seeing right now, which are some of these biggest challenges. So let me, at a super simplistic level, try to explain the simple tricks of cybersecurity business which you've all grown up with. So the simple trick was when it came to any computer program, make sure that it is tested as much as you can. And once it is tested, put it in a secure zone, which you can call either a DMZ or a secure data center or a completely watertight area so that nobody can change whatever has been tested. So test it thoroughly and then secure it. And after that, any smallest change of code for that has to go through some kind of change control process. Now that was an easy task, which is put all your effort to test it once and protect it forever. In the self-learning models, or in even the world of DevOps kind of development model, it is very hard for us to test the program once and live with it for a long time, because the machine learning models or the self-learning models are designed to change. So how do you live with this world where you thought that you tested something and it remains the same forever? That first fundamental principle gets broken. The second thing is that in the past, the programs changed when somebody went and changed the code. But now in the machine learning models, the program's output changes not just by the code, but by the data. So you feed in data of one type, it'll behave in a particular way. You feed in different kinds of data, it'll learn to behave in a different way. That's how the whole evolution of self-learning models or the machine learning models is. So now the attack pattern is not just changing the code or running a malware on top of it. You could actually feed wrong kind of data, which is what is typically called the data poisoning, and that will make the program behave in a very different manner. So there are some of these very interesting dimension of control which we in the classical world of programmatic technology haven't done, And those are the kind of challenges which we have to deal with. The good news is that it's not that they're impossible to deal with, but they are just different.
So, what is when you spoke about data poisoning? I think that's a very interesting example, because if artificial intelligence or machine learning, the output is all about the data that you feed into the machine. Now, for instance, in use cases like healthcare, wherein let's say for a hospital, or let's say those kind of use cases where the kind of data that you actually input into the machine can have life changing impact, can actually impact the life of a person. So besides that, what are some of the areas and implications of security threats that such kind of data poisoning can lead to?
So first is the good news is that in number of mission critical activities and especially life threatening activities, we are dealing with a part of AI which is supervised learning, and we are not dealing with unsupervised learning. The supervised learning allows only certain set of data sets to be credible, which means that the people who control that program control what kind of data can be used to change the behavior of the program. There's another set of things which is unsupervised learning, where the computer learns by itself. Now, good news is that we don't put that on life critical or mission critical activities. We put that in many other interesting use cases. So one such good use case is chatbots. So for example, you gave the example of a Siri or an Alexa and all of that. How do they learn? They learn it because every single day they are learning to understand my voice. And the more I speak to Alexa, the more it gets better in understanding my voice. Now that's at some level is can be an uncontrollable technology. So wherein if somebody fed into Alexa, my voice being somebody else's voice, that could be one example of this thing. There's some other examples where there are public chatbots which have been poisoned to give wrong answers. So they learned to do say the right thing, and then people fed lot of bad things, and then they started to say bad things. There are other examples of data poisoning where somebody's credit scores can be manipulated, which is, if you start to feed wrong data. So you say that, people of category A, B, C, give them loan when you should actually not be giving them loan. And then the system will start to give loans to all those people who are actually not credit worthy. There are many examples in this world which we live with, where the data poisoning can actually have significant misjudgments if the AI is not well controlled.
But do you see that going forward, we are going to see unsupervised learning finding its way into mission critical applications also, leading to more far reaching implications?
Uh, I'm not so sure if we'll see that in short term, because we always the introduction of a new technology is a risk reward equation to say what is the reward we get for the risk which we do. But I think where the boundaries get blurred is the extreme example of life saving things and the silliest example of chatbot. There are lots of things in between which the businesses consider as a business critical information or business critical decisions. I see the unsupervised learning getting a lot in those areas, which may not be life threatening, but can be sometimes existential issues for the organization. So those are the areas where I think the risk reward equation sometimes cannot be as simple and as clear. And I see those getting neural network based or advanced deep learning algos to make decisions, and there we can cause some challenges.
So, have we seen instances, or have we seen an increase in attacks on the algorithms, on the AI systems by the threat actors, by the cyber criminals? What kind of trends are we seeing there?
Yeah, absolutely. So I think there are many examples where the attackers have tried to take control. But what I would say that the good news for the attackers is that there are so many of our classical systems which are so vulnerable that they are also trying to maximize their ROI in attacking some of these basic things rather than going after some of these most complicated things. But there are a number of examples where the AI systems have been attacked. Let me talk about a slightly different take on how attackers are taking advantage of artificial intelligence and they are causing challenges in our world. So let me introduce the concept of deep fakes. And the deep fakes are nothing but where the attacker is saying that, as much of AI you as an organization have, I also have access to the same AI. So you are trying to make certain decisions, I will also make those decisions. You are trying to do certain things, I'll do the same. So there are two or three branches which the attackers are using AI to attack us as humans as well as our AI system. So the first one is the big thing happening in deepfake, wherein you could potentially appear to be impersonated either by your voice tone or even by your video. So that is something which I would say has far-reaching implication in our world. Because today, how do we trust each other? We trust each other that when I speak to somebody on phone, so I say, phone is coming from Shipra, person sounds like Shipra. She must be Shipra. But the AI technology today allows a little bit of your voice samples, and those voice samples can actually be fed into a synthesizer, and that synthesizer will talk to me as if it's Shipra. So similarly, there's a deepfake videos where it could be just you and I having this conversation, but somebody can actually superimpose someone completely different using the same facial expressions and voice notes. So imagine in our virtual world where we don't see individuals face to face, and the only way we rely is the Zoom meetings and team meetings. What if you're talking to a deepfake? What could happen in those situations? Now, it's if you look at if you trace back the history of why deepfakes, actually deepfakes have come up as a result of us as humans trying to optimize our world. So the root of deepfake goes into the animation film industry, because in the animation film industry you don't want a voice artist to spend all the time. So you train a voice artist voice like an Amitabh Bachchan or a George Clooney, and then you just feed in the text and the machine does it. Similarly, the deepfakes on videos came over that. So all the investment which the organization do in using artificial intelligence for great human use and outcome also gets exploited by the attackers. The second type of attack which we see on the attackers using artificial intelligence is really modeling people's behavior. So when they say that, if I know that Shipra follows this behavior every single day, I can attack her when this is the most vulnerable moment because your machine is unattended at that time, or you might not be. So those are some of those things which are developing. I would say that, it's while it's a great problem for us to worry about, the real damages so far are not that many. But like any other exponential growth technologies, it's a matter of time when we hit that inflection point, and after that it might be very hard for us to catch up.
And do you think that inflection point is going to come in the short term or the long term or the medium term?
It could be as hard as predicting when the next wave of COVID-19 will come. But I think it's I always say in technology world it's sooner than when we anticipate. So it'll come soon. Why we are all not hitting that inflection point today? Because a lot of AI deployment in organization is still in a controlled manner, in a POC modes, and not like widespread. So that's one area. But I would give you many example of misuses, which the unattended surveillance. There are some interesting stories, which, but again, not at a massive scale right now.
But as the proliferation of AI within the enterprises grows, and as it becomes more mainstream, and organizations look at more and more use cases, I think that's when the impact from a cybersecurity perspective is going to become more clear to the organizations.
You're right. In fact, I would say organization can take a stepping stone right now, is because while the AI is still going in a relatively controlled manner, the robotics technology is going rather fast. And most companies had deployed these RPA technologies, which is using process robots to fast track certain things. Those bring in certain risks which are sort of, I would say, hybrid between completely programmatic technology and a completely self-learning or machine learning technology. Those are here now, and there are a lot of those attacks which are happening in those places. Because in this particular case, I just need to take control of a bot, and then that bot can do a lot of things. Because unlike a human machines which are attended, many unattended bots do certain things which go unnoticed. So there are some of these attacks which are happening there. So my advice is that let's start to focus on those here and now risks, and then so that we are better prepared to deal with some of these future attacks.
So you mentioned about attacks on the unattended bots, RPA. So have there been such instances in the world
Yes,
in
yes,
real business life?
that's right. So there are unattended bots which have been compromised to because many times the passwords are hard coded in those. So they have been. So now the good organizations actually have better command and control systems, which actually, so there's a bot for a bot, which kind of controls what a bot is doing. So they are trying to predict, but there are some examples of unattended bots being compromised.
Right. So it's important that organizations right now, when they are still, kind of working on their AI strategy, they kind of embed those principles of security and with in that bring in that layer right now when they're building their AI systems.
Absolutely, I think there are a few things which the organizations need to do. Number one is they need to be prepared that the world is changing, because a lot of our security organizations may not have recognized that the world is changing. So rather than playing a catch-up game, can we be a little bit ahead of the curve? The second is to bring in those kinds of skills, because to solve the AI security problems, you need very different kinds of people. So at least the people who understand how AI systems function. The third one is being part of the deployment cycles, because we as a security community have been talking for a long time as security being embedded rather than being bolt on. A bolt-on security on AI can be rather hard. So it's time for us to bring security by design as we talk about the machine learning systems.
Yeah, those are some great suggestions for CIOs and CISOs to consider. My last question is does rogue AI exist, and what kind of challenge does it hold if it does exist?
Yeah, I think the rogue AI certainly exists. Sometimes it's created by people. Sometimes it can get self-created. So there are interesting stories around it. Of course, there's the good news is that there is nothing which has been caused as a massive thing. There are also definition challenges of saying what is a rogue AI, because when you use the term rogue, it kind of blends in what is the expected outcome versus what is the delivered outcome. Okay, so when the delivered outcome is different from the expected outcome, it's a rogue AI. Now, like humans, we don't have the concept of right or wrong, morally right, morally wrong, those kind of things. So there's a big play of ethics in the machine learning world, which has not yet been fully explored, or I would say fully dealt with. So I'm sure you come across this is called the classical trolley problem, in which uh, imagine a train is coming running down the track, and there are five people sitting on the track. Now the driver of the train has to make a decision whether to stop the train and kill some people in the train, or let the train go and kill four people on the train track. Now, those are typically called the trolley problem or the ethical dilemma problems. Now, as a human, we don't solve these problems. We don't discuss these problems. So, as a train driver, it is left to you. When you're driving that train, what happens? And maybe there are some rules around it, etc. But when it comes to building machines, you got to build it in. You can't say we will see. There is no concept of it depends. There's nothing. So you got to design for those possibilities. Now, interestingly, you can put weights. So you can say that maybe till time there are two people, it's okay to kill. When there are 20 people, it's not okay to kill. So you can define some boundary condition of that. So there's a lot of research happening on the ethical side of machine learning. There are lots of things happening around that area. I hope we'll find some slightly better solution. So that causes something as rogue AI. The second thing which causes rogue AI is the poisoning impacts, or people when they develop certain things, they either misrepresent or they avoid thinking about certain kind of possibilities. So yes, there are a lot of rogue AIs which can be either from an ethics standpoint, performance standpoint, a wrong decision standpoint, but I think, like all of us live with the world of good and evil, the balance is in the favor of good. And I think the balance is greatly in favor of good when it comes to AI right now.
So we are not going to be seeing a Terminator kind of a
Not at all.
situation for
Not at
rogue
all.
AI.
I,
And,
I, I'm ever optimistic about that, and we will be happy humankind.
Great, Akhilesh. I think it was fascinating talking to you. I think the kind of examples that you give, I think they just add so much of nuance to what you are talking about, and you can actually understand it better. Thank you so much once again, Akhilesh, for your time, and hope you have a great day.
Thank you so much, Shipra. It's always a pleasure to talk to you. Wonderful. Thank you.